All right, in this question here, I'm going to show you how to prove an identity using the idea of a conjugate. If you don't remember what a conjugate is, for the binomial a plus b, the conjugate will always be the opposite, so a minus b. So when you're proving identity, one thing you can try here is to write everything in terms of sine, cosine, or tan. So as I can see here, first of all, on the left-hand side, cosecant and cotan, I can rewrite both of these using the reciprocal identities. So I have 1 over sine theta, which is a reciprocal of a cosecant, plus cotan theta, which is cosine theta over sine theta. So that takes care of the left-hand side. Let's go move over to the right. Cosecant theta is 1 over sine theta. Subtract cotan theta, which is, again, cosine theta over sine theta. So at first glance, it looks like it got messier than it initially was, but the idea is to cancel things out to make each side equal to each other. So for example, on the left-hand side, you'll see that we do have fractions on the bottom, but what's nice about these fractions is that they have the same denominator, so I can go ahead and add them. So I get 1 plus cosine theta over sine theta. On the right-hand side here, once again, we do have the same denominator, so we can go ahead and subtract the top. So 1 minus cosine theta. This is all over sine theta. So on the left-hand side here, we are dividing by a fraction. So that is the same thing as multiplying by the reciprocal. So if I take the reciprocal of the bottom, what I end up getting is sine theta over 1 plus cosine theta. This is equal to 1 minus cos theta over sine theta. So you'll see from here, they do not look anything the same. They look pretty close, but we can't conclude our proof just yet. So part of this question is we have to apply the conjugate. So it actually doesn't matter which side you do manipulate. For this example, I will manipulate the right-hand side. So what I'll do at the top and the bottom here is multiply by the conjugate of 1 minus cosine theta, which is 1 plus cosine theta. So both the top and the bottom will be multiplied by that binomial. So I'm going to leave the left-hand side the way it looks and just start by simplifying the right-hand side. So what's nice about expanding conjugates is that you end up getting a difference in squares. So a minus b times a plus b gives you a squared minus b squared. So if I expand the top, what I'll be left with here is 1 squared minus cos squared. And this is all over sine theta times 1 plus cos theta. Okay, all right, so as you can see in the top here, 1 squared is just simply 1, so I can get rid of that. And the top is actually an identity. It may not be clear at first because you actually have to manipulate one of these identities, and it is the first one. So for example, right here, sine squared theta minus cos or plus cos squared theta, I can manipulate that to get this expression here. To get it, I actually have to bring the cosine theta to the right-hand side, and what I'm left with is sine squared theta is equal to 1 minus cos squared theta. So I can replace the 1 minus cos squared theta with sine squared theta. And you'll see I can start to cancel some terms out here because what we have on the top is a sine squared, so that will become 1 sine. Sine goes away on the bottom, and what I'm left with is sine theta over 1 plus cos theta, which I believe is now equal to the left-hand side. So that actually concludes my proof.